Hey guys, I'm in a new area today. I'm in my kitchen, but let's talk about incenters and circumcenters. So I have my paper here, and I'm just gonna show y'all like what these individually are, like circumcenter and incenter, because they're confusing, and also like how to tell them apart. So first, let's talk about circumcenters. So let's like ignore this, cause like what the heck does the perpendicular bisector of the sides of a triangle intersect at a point called the circumcenter? And yes, it's good to know this, but like you should be able to understand what circumcenter is with just simple words, because honestly, you don't need to understand like equidistant, for example. Well, equidistant means that it's an equal distant. So yeah, but like honestly, like it's just kind of unnecessary. So I'm just gonna tell y'all like the simple ways of understanding it. So basically, what a circumcenter is it's this little dot, and then the lines that come out of this dot divide the three sides into equal things. So this first side is divided into two parts, equal parts. This side is equal to this side. This one divides these AC into two equal parts, this side and this side. And then AB is divided into two equal parts, AD and DB, and they're both equal. And then here it says the circumcenter is always equidistant from the vertices of the triangle. So all this says is that the circumcenter is always in equal distance from each place. So this is equal to this and this, so they're all equal. So now let's look at incenter. Don't look at my drawings. Anyway, so in the incenter, it's kind of like the circumcenter, but instead of dividing the sides, it divides the angles. You get me? So, like, as you can see right here, this incenter bisector thing, it just bisects the angles so they're equal. You see? This one, too, and this one. And also, it also like makes these sides equal and these sides equal because they're always equidistant from the sides of the triangle. So again, I'm gonna say it. How to differentiate these two is that the circumcenter divides the sides into equal pieces, and then the incenter divides the angles into equal numbers. Okay guys, so let's do number 3. Don't mind my drawing. I already did this question, but let's do it again for y'all. So let's look at GI. Oh, hold on. Let's set our like pre-existing knowledge, our givens. So what you know, why isn't it focusing? So what we know is that this is the circumcenter. So in circumcenters, you know that these are equal, the sides are equal, and these are perpendicular bisectors, so these are 90-degree angles. So now let's do GI. So GI is right here. So it already tells you one of the lines that GI is a part of, which is 30, and we know that the other line is equal to 32 because they're bisected perpendicularly. So 30 plus 30 would be 60. Okay, why isn't it freaking focusing? Okay, whatever. So now let's go to MH. So MH, let's see, MH is right here. It's this one. So this one uses the Pythagorean theorem. So basically, we know that 31, that this angle is equal, JH is equal to GH, GJ, because they're perpendicularly bisected. I don't know if that's a real word, but I'm just going to use that. So that's 31. So now let's do the Pythagorean theorem. So let me calculate that. So after I calculated, I got 34.1. That's approximately because squaring this is not a whole number. So now let's move on to IK. So this is IK. And so we know that the circumcenter is always equidistant from vertices of the triangle. So this means that all these angles are equal. So that tells us that this angle, and this angle are equal. And we already found out what these angles are, which they're 34.01. And I'm just gonna round that to 34 because I'm lazy. So this is 34, and we're looking for IK. So what is happening? So IK is IK is 34 and 23 in this other leg. So let's calculate that. So it'd be x squared plus 23 squared equals 34 squared. So let me calculate that. Or since we know that like this squared, let's do this. So since we know that this one comes from IH, and we already know like what it's squared to, so I'm just gonna put that number and let's see. Okay, so what I got was 25.6. Oh, let me do that approximate symbol, and now let's do IH. Oh my gosh, what the heck? Hopefully y'all can still see that. HI. And we already know IK, which is half of that because they're perpendicular bisectors. So 25.06. So let's just add that together, which would be, I guess it's approximately 50.12. Okay, so this is the incenter practice problem. And I know it's a little easier, but I cannot just turn down my amazing student Alex's request for this problem. So let's do it. So we're trying to find x. And we know the incenter is k, and yeah. So basically, let's put out our givens first. So we know these two are equal, and then these two are equal. So we know this full angle is 54. This full angle is 38. And then we can just like we can just use the understanding of, since all these parts equal 180. Oh shoot, sorry. They're 180. So we know that 54 plus 38 plus this angle equals to 180. So plus 217x minus 7. So let's do distribution and then put these onto this. So I just did that. So I moved them over here and then brought my hair. And then 17 times 2 equals 34, and then just do like your normal adding, subtracting, PEMDAS, and then you'll get that. I hope you liked that video, and shout out to all my supporters, and bye guys.